Hello, and thank you for your interest and time today. I am David Massey, Vice President, Business Development with MaXentric Technologies. I have over 37 years of experience developing advanced RF technologies for the DoD and the commercial markets. Today, I will review our Navy Phase 2 SBIR project, High Dynamic Range Multi-Merits Carrier Amplifier Program, and talk about its benefits for the Navy and where we are with the development of the technology for future ship communication systems. But first, an overview of MaXentric Technologies. MaXentric Technologies is a small business with a focus on advanced RF technology, research, and product development. We focus on technologies and products for the next generation of advanced communications and radar systems for mobile platforms. We have offices and laboratory space in La Jolla, California, and Fort Lee, New Jersey, and we are opening a new office in Boulder, Colorado in the May-June timeframe of 2021. We currently have a staff of over 50 engineers with over 20 with PhDs focusing on both military and commercial customers. Our client base includes commercial customers such as Verizon, Sprint, Cablevision, SiriusXM, and Airbus. And our government customer base includes DARPA, NASA, MDA, Air Force, Army, Navy, and DHS. In wireless systems, we are developing next-generation wireless technologies to introduce capabilities and enhance proficiencies, particularly in the microwave and millimeter wave bands. Our product areas include ad hoc wireless networks for airborne communication platforms, high-resolution imaging radar, software-defined radios, simultaneous transmit and receive systems, and LPI, LPD radar and communication systems. Our RF and digital signal processing platforms include mixed processor systems for improved performance and design flexibility. These systems include FPGAs, mini-core GPU, CPUs, digital beamforming, RF SOCs for radar and communication systems. MaXentric also develops custom ASICs for RF systems, including linearization and digital pre-distortion for improved amplifier efficiency, as well as custom 5G RF SOC solutions for miniature data links, including Type 1 encryption for handheld radios in Army, Group 1 and larger UAV platforms, where SWaP-C is critical to mission success. Finally, and for the topic today, MaXentric is a world-class leader in the design of linear wideband high-efficiency multi-carrier amplifiers for satellite and mobile communication systems. The Navy's Digital Modular Radio program has been upgraded to support a wide range of waveforms, including SRW, Half-Quick, SINGAR, SATCOM, MEOS, and Saturn. To further increase the fleet's warfighting capability, the U.S. Navy is interested in reducing the number of single-function RF systems required on Navy ships and submarines. The Navy's significant advancements in DMR have not addressed the limitations of RF amplifiers and combining systems. The legacy RF amplifier systems do not have the flexibility and reconfigurability of the DMR and have significant limitations and inefficiencies in bandwidth, power consumption, size, channel capacity, and interference mitigation. Embark addresses this need for an efficient wideband multi-carrier amplifier. Increased sophistication of our peer adversaries, jamming and surveillance capabilities demand full and efficient use of the RF spectrum by the U.S. military. Obsolescence and inability to deliver resilient command, control, and communication RC3 capabilities is hindering the Navy's ability to counter this threat. Legacy hardware based using multi-couplers and very bulky and cannot support advanced frequency hopping waveforms such as Saturn, needed that offer anti-jam protection of our capabilities. The current Navy budget does not account for upgrades to support the RC3 capabilities and inefficient use of the RF spectrum. Upgrading the legacy equipment is proving to be cost prohibitive and unsustainable. Therefore, Embark provides a solution that is timely and in need by the U.S. Navy. Pictured on the right is the Digital Modular Radio, software-defined radio, and a host of ancillary amplifiers and coupler systems that are used to make a complete system on a variety of Navy platforms. Multiple DMR chassis can support additional channel capacity, which requires additional amplifiers and filtering system, which are frequently band dependent. Current shipboard amplifier technology does not support simultaneous multi-channel, multi-carrier broadband communications capability. Several possible solutions have been ground tested for other situations, including multiple amplifiers and coupler systems, but they have had limited success. Significant issues with size, weight, and power must be overcome in order to make use of the flexibility of the DMR in terms of frequency coverage and channel capacity. Through our Embark and Hot Nails programs, we will provide revolutionary improvement in the performance of shipboard communication systems for tactical operations. The SWaP-C improvements will also allow for lower O&M costs through lower AC power consumption, cooling required, and the size in the shipboard radio rooms. The improved MTBF and MTTR of the system will provide for additional cost savings for the Navy while improving performance. The Embark and Hot Nails multi-carrier amplifier is designed to match up with the channel capacity of the DMR at 4 amplifiers per 4-channel DMR chassis. Multiple DMRs can be paired with multiple Hot Nails Embark chassis to expand the number of channels supported. We have a wideband design that utilizes devices with a sweet spot for wideband matching at VHF and UHF, and we use resistive feedback for our wideband HF design. We introduce even harmonic suppression in a push-pull configuration with wideband balance. Therefore, no tunable filters or filter banks are needed. We also have odd harmonic suppression using balanced configuration with 90-degree hybrids. We use digital pre-distortion to remove additional harmonics, and that results in an amplifier that needs no tunable filters or filter banks. Very high linearity using our MaxPal digital pre-distortion technology and wideband equalization. High efficiency for multi-carriers is part of our Adagio product line of envelope tracking, and we use COTS devices whenever possible. Our solution is low risk, low cost, and reliable. It's based on an LRU amplifier module that's easily replaceable for failures in the field, and the system is scalable, replaceable, and has low maintenance cost. All of this is based on proven design technology at MaXentric. The Embark and Hot Nail schedule reflects a base program within the scope of SBIR funding, which is noted in blue. The orange schedule reflects tasks to be completed in optional funding based on availability and resources at MaXentric and the Navy. The orange schedule has been partially funded, and we have completed a prototype of the multi-carrier amplifier at UHF with testing in March. The green schedule represents tasks that could have been done in parallel or delayed to a later date based on availability of funds and resources at MaXentric and the Navy. As a top-level overview of the Embark Hot Nail specifications, we have a building block output power assembly of 250 watts. We support digital interfaces to the DMR and also commercial standard VITA 49.2 and ANSI 5041. The amplifier supports multi-carrier operations, and we can do up to 36 concurrent channels simultaneously. The amplifier can support frequency ranges from 2 megahertz to 3 gigahertz. We offer very high linearity with selectable pre-distortion modes. It's very, very efficient with over 20% improvement over typical Class AB amplifiers. We can introduce a star coupler for simultaneous transmit and receive, sampling of the output power, and it is integrated into a standard 19-inch rack mount with air cooling. We can also support liquid cooling if that is the solution needed on certain platforms. Currently, we support AM, FM, PM modulated waveforms in the HF, VHF, UHF, SATCOM, and UOS bands. And we offer a control interface directly to the DMR through Ethernet. Additionally, the current Hot Nails design will reduce the below-deck rack space of the legacy UH amplifiers and multi-couplers from 4 racks down to 2. For a 16-channel system, we can go down to 1 rack. The weight, shipboard power, and cost will also produce significant cost savings for the Navy. Currently, the Navy's transition target is the DMR program through PMW A170. We've had additional discussions regarding the amplifier system for aircraft and tactical ground vehicles that have fewer number of channel requirements than most of the current ship classes. On successful completion of an EMD by PMW 170, a target ship class will be identified for transition. As an example, FFGX or it could be a flight upgrade to another ship class. The amplifier topology offers affordable, scalable number of simultaneous channels across the HF through C-band frequency ranges with up to 4 to 36 channels. Although not currently funded under Hot Nails, MaXentric is developing a multi-carrier amplifier in the 1 to 2 gigahertz frequency range, and we also have a multi-carrier amplifier program at C-band. The system supports communications, both line of sight and beyond line of sight relay capabilities for the surface fleet. Amplifier designs can support frequency domain, multiple access, or TDMA waveforms simultaneously. And the amplifier can also support commercial 5G waveform standards such as OFDM and 64 QAM. And within the same band of operation, we can support 5G and DoD waveforms simultaneously. Wideband gain amplifiers, software-defined radios, and data link systems continue to shrink in size with increased performance. MaXentric's wideband amplifiers, modems, and digital beamforming systems for radar and communication application markets segments continues to grow within our company. MaXentric has developed wideband amplifiers for SDRs, digital beamformers, and arrays for the radar and communication markets for both DoD and commercial customers. Wideband multi-carrier amplifier systems can provide higher RF to DC power efficiencies, which will reduce your swap C on your platform. Rapid development of these systems is achieved by commonality in the interfaces and digital baseband interfaces between the SDR and the existing communications and radar equipment. MaXentric has adopted many of the open architecture standards such as VIDA49, MOSA, SOSA, and CMOS standards into our interfaces for amplifier control and operations using COTS components and off-the-shelf racks. And these systems have already been qualified to shipboard MIL standards, such as MIL standard 461 and 810, which will expedite EDM testing and transition to a product for you. Wideband gain amplifiers, software-defined radios, and data link systems continue to shrink in size with increased performance. MaXentric's wideband amplifiers, modems, and digital beamforming systems for radar and communication application market segments continues to grow. MaXentric has developed wideband amplifiers, SDRs, digital beamforming, and array systems for radar and communication markets for both DoD and commercial customers. The wideband amplifier multi-carrier amplifier systems can provide higher RF to DC prime power efficiency, reducing your swap C constraints currently on your platforms. Rapid development of these systems is achieved by commonality in the interfaces and digital systems between the SDR baseband signals and the amplifier. MaXentric has adopted many of the open architecture standards such as VIDA49, MOSA, SOSA, and CMOS into our interfaces for amplifier control and operations using COTS components that have been qualified to shipboard MIL standard requirements such as MIL standard 461 and 810, which will expedite EDM testing and transition to production. As a wrap-up on this briefing, MaXentric's technical lead and principal investigator on Hot Nails and Embark is Dr. Johanna Jan. Johanna is MaXentric's lead engineer in RF power amplifier systems. Her office and labs are in La Jolla, California, and her contact information is noted above. If you'd like to discuss some business development related questions or plan a visit to see some demonstrations of our multi-carrier amplifier technology or other RF advanced products and technology, please give me a call. Dave Massey, VP of Business Development, MaXentric Technologies Corporation. I think MaXentric Technologies is well positioned to continue to grow in this niche market of wideband high performance amplifiers. Additionally, customized Cs, software-defined radios, and RF systems where you may need digital beamforming or some custom waveform development in both commercial and government sectors. Thank you for your time.